Hello. Um, I'm going to talk about my findings and doing some experimentation with browser performance. I read a very good article um, at the beginning of the week on reflows and repaints in the browser, and um, this is the article, and I'll link to it in the YouTube. I invite you, the viewer, to read through this before watching my presentation or blog, and then come back and you know listen to what I have to discuss, um, uh, and how I tested things out um, based on this article. So, or if you don't want to, then don't, and I'll just give a brief summary of what this article is about, and you can go from there. So, um, essentially, the browser is, or the a document in the browser, like this page, has a layout and um, um, visuals with different colors and that sort of thing, and changes to the the a resizing of the window or scrolling, stuff like that will result in relayouts and repaints. And of course, changing the background color of a div will just be a repaint. Um, Adding a header to the top of a long page will result in a reflow or relayout, and that'll affect a lot of data because a change at the top is going to bump a bunch of the visual data down the page. So um, this results in some best practices when doing DOM scripting. Um, the author, who I should probably mention, this guy is still young, it looks like. I'm pretty sure it's a he, uh, says definitely beware of reading layout data. So if you have your scripting, DOM scripting code, and you make changes to some DOM element, and then right afterwards you do a read on a DOM element further down the page, well, that makes it so that the browser must do its relayout for the scripting to get what it wants. If it doesn't, then it does it at the end of the code being finishing executing, and then does a relayout because that is what is needed for showing the change on the page. Yeah, so that was the big takeaway I got. Beware of reading layout data. Another one was to cache your data, um, and I'll just use his example because it's a good one. Um, oh, where is it? Yeah, like cache your data. Don't keep on accessing um, uh, elements, visual properties, like in a big for loop. Cache it and work with it without accessing the visual data off the DOM element. And the other one, which will be an important subject of discussion later in this presentation, is using, like he says here, using document fragments as opposed to appending child a bunch of times. And I got into some some more detailed findings about this aspect. If you don't know how document fragments work, look them up right now. They're really cool. Um, they're basically um, this tree that is not the document uh, model, the live document model. Um, it's like these trees that are like document fragments, quote unquote, that you can append children to, append nodes to, outside of the DOM, and then all at once append to the DOM. And the idea there, as you're probably reading from the article here, is there's going to be savings and efficiency gains by uh, batching all of your append childs into a document fragment, and then all at once appending to the DOM. Now, that's the down low. For relayout repaint, I don't want to take the thunder of this article. I am going to link it and say, hey, you, the viewer, please read this, come back to this presentation, or put it in your read later and continue watching my pres. Okay, so this author cued me in on a part of the developer tools for the browser for analyzing performance, looking at how long it takes to do code block execution, how long it takes to do the rendering or relayouts, how long it takes to do the repaints. And there is a part of the developer tools, I use Chrome's developer tools, that is performance and has a timeline of actions on the browser page that you can record. So let me first, before we look at it, I'm going to explain my first test, and then we can see the performance timeline for my first test. So to explain my first test, I have a lot of content here. You can see in my full view of my document. And this is all HTML down here. Over here, if I scroll down, you'll see it. And I wanted to see I wanted to see in today's modern browser what doing a performance no-no does in terms of impacting browser performance. That article was from 2009, and I thought, let me see if I can perform a no-no and have it be a real hit, an actual performance hit. This is me being a good tester. The article came out from 2009. I want to confirm and verify that that relayouts are still still be a drain on performance potentially. So we're going to be concerned with this squisher function first. So I have my button squisher, squish container width, and it's going to take the bootstrap container, which normally is like 1100 something pixels, and squish it to a width of 500, right? And then I'm going to get the last header node, accessing it using jQuery, but then getting the node that is wrapped by getting the first element of the jQuery array of elements gotten by the jQuery operation. And then I'm going to do the no-no, which is to access the visual property data of the header node using get bounding client rect. Get bounding client rect is a report on the width and height of the box of the element, including top, left, right, and bottom, which is in relation to the document and not the view screen. So if there's a lot of scroll content, then top is all the way up to the top of the page. I'm pretty sure. I don't know for sure. Okay, I'm not gonna to look that up, but I think that's the case. So, you know what? Let's look it up. It's good to spell check oneself if one does not know exactly what the definition of a thing is. So top left, bottom right. Oh, oh, they're relative to the viewport. Okay, I was wrong. This means that the rectangle's boundary edges, top, left, bottom, and right, change their values every time the scrolling position changes. Oh, okay. And it says here, yeah, if you need the bounding rectangle relative to the top left corner of the document, just add current scrolling position to top. That makes sense. Cool. Okay. Well, I just reinforced my my knowledge of get bounding client rect. Okay. Excuse me for that. Now getting back to the squisher function. So the squisher is going to take it's going to take all this content and make it 500 pixels wide, and then I'm going to get the bounding client rect for the last header, this guy right here at the very bottom of the page. So even though it's getting bounding client rect, and this is data in relation to the viewport and not the document, the data above end of page 4 is going to impact the bounding client rect, right? So all of this data, including the lines having to redo themselves, which is a big part of impacting rendering, determines the bounding client rect for the header here. So I'm going to go ahead and do the test and bring up my developer tools. Here's the performance part. And I'm going to hit record off screen, but I'll bring this back over when we're done with the test. Alright, we squished it. I'm stopping the test. Alright, here we go. Picture the heavenly trumpets blaring and the awesomeness of this performance test here. And this whole Chrome performance console. It's very cool. Oh boy. So purple is rendering. So right around 4 seconds into the recording is when I clicked on the squish button. And you can see here, you know, this lime green is code executing in the stack. There is a mandate by the call to get bounding client rect to do this relayout code within the code execution. And you see here, like this pie chart shows how much time is idle, how much time is rendering, painting, scripting, and a ton of it is rendering. So that's the lesson, and that's the significance and importance of this first test. 2018, 9 years after that article, yes, it still is important to beware of reading layout data in code execution. So you may have to do it. You may want to be wise when you do such accessing. Alright, that's the first test. Now, what's my next part? So, yeah, getting back to the document fragment. In the article, one of the best practices for browser performance is to collect your nodes and appendings into a document fragment and not do one-by-one appendings to the DOM. And I thought to myself, well, you know, if you're appending to the DOM in your code execution, there's no mandate that says there has to be rendering done because you're appending to the DOM as opposed to appending to a document fragment. So does one have to follow the best practice mindlessly? No. This first example here, I'm going to have one button that adds 4 headers where they're appended to the DOM one by one. That's right here. So one by one is gonna do document append child first header, document append child second header, and then 3 and 4. Fragment appender is going to do a fragment, 4 appends to the fragment, then 1 append to the DOM. And we're going to see the performance results for both. All right. I don't know why, but it seems to make more sense to be quiet during the testing. Okay, so this was the one by one. Okay, so I was able to click into the code block on the timeline, and yes, it is my one by one appending. I'm appending headers. I'm making the headers here and then appending them to my node here, which is a part of the DOM. It's a one by one appending, and you can see here that there's the code block, and then there's the layout and rendering processing that happens after. Okay, cool. Like, this rendering main chunk here is 2.3 milliseconds. Painting 2.3 milliseconds. Okay, great. Now, let's do the fragment appending. Okay, let's see here. This looks like the area. Indeed it is. Fragment append function. And voila, 2 milliseconds, the same, it's the same thing. Okay, so you don't have to mindlessly follow that rule, but use your understanding, and maybe document fragments better because you're collecting your nodes in this, I don't know, document fragment, something like that. There's reasons why. So I thought about, okay, well, let me try to think of a way in which document fragment appending is beneficial in terms of performance. And my aha there was a lot of these frameworks and a lot of JavaScript code is asynchronous. And I thought, well, what if there was a tasking of doing DOM appending related tasks asynchronously, and this asynchronous, the asynchronous usage and frameworks is all for performance, right? Like you can go back to things that are being processed and check and see where they're at, and not have heavy weights on your whole system operating. So that's where it's beneficial to have processing of a system and its various aspects and responsibilities be asynchronous based. So I thought, for this next test, why not replicate that and have timeout firing of appending to the DOM, and timeout firing of appending to a fragment, then append to the DOM at the end, right? So between those two is appending to the document fragment with timer events going to be better than appending one by one to the DOM and timer events. And I will tell you that yes, the document fragment did help, and you can probably take an estimated guess that doing the document append child results in something along the lines of taking time the the browser taking time to do relayout after appending each document, um, after appending each header to the document. And we'll see what the results are like. It kind of follows that pattern, kind of doesn't, but there is a bit of time savings without doing it that way and with appending to a document fragment. So let's see. I'm gonna zip forward to my my new test code. Oh, doesn't want to zip forward. Okay, give me 1 second. I gotta get that code. Shoot. Where did I put that? Bear with me 1 second. I have a dirty workplace, which is fine. My workbench is dirty because I've been testing and experimenting and iterating. I'll stay zoomed in so it can be read on YouTube. Okay, so I have a do tasks function. We'll look at the one-by-one appender and the do task function first. So do tasks works off of a count, which is the current amount of remaining tasks to do. Has a task to do every time, and then a final task when the task given a certain amount of count times is done. And for one-by-one appender, my task is right here, and you can see making the header, appending to the document and placement area. And let's check this one out. Alright, I'm going to set up my test. Here we go. Okay. Oh. Right around here, we can see there's the area of importance. Alright, here's do tasks. Here's render and repaint, right after the first timeout. Here's do tasks again, and that fourth time. There's not a render right after appending to the document second, third, fourth time until way over here. So there's like this dead space where it doesn't update. Who knows what's going on here? There's probably some important browser processing, but interesting, right? So we're seeing this relayout and repaint happen right after the first append. Now let's look at appending to document fragment, then having the 4 tasks happen one after the other, appending to document fragment each time, then appending to document. Okay, here we go. All right. Zoom in on the area of importance. Oh. And interesting. So there's a repaint. Even with appending to document fragment, there's a recalculate style, but there is not that bigger bar from the previous test, which was the update layer tree. Or was it layout? But there was, remember, if you go back in the YouTube timeline, you'll see that there was a lot bigger bar, purple bar, and a more time being used after the first timeout. Here, there's less time, more performance going on here, right? You're saving that time where this could be other processing being done in this time, and resulting in the whole system being able to process its processes quicker and achieve better app performance overall. So do tasks, just like before. Do tasks. That's not do tasks. Do tasks. Do tasks, and just like you saw, and we'll confirm it is the fragment appending going on. So that's it for this video blog. Thank you for viewing. In summary, browser performance rocks. Use the performance console from now on. It's really cool, and start thinking in terms of performance. If you're doing code execution, beware of accessing visual data, because that might result in relayout processing on the part of the browser, and lead to sucking up of resources. And be smart and be crafty with when you need to have that relayout happen, that rendering processing happen, and start thinking in those terms. I know I'm going to start thinking in those terms, and I'm going to be looking at my apps that I develop in those terms, and in those terms is just a really nice line to say at the end of this presentation too. So that's it. Thanks for watching. Have a good one.